Example, graph y equals negative 2/3 x plus 2 by hand and using a calculator. Okay, let's try this out. So let's make a quick sketch, but first of all, let's remember that our equation y equals mx plus b. And therefore we have y equals negative, our slope, 2/3 x plus b, b value is 2 in this case. So y equals negative 2/3 x plus 2. And let's realize that our slope, m equals negative 2/3, that's our slope, and it's in the form of rise over run. But in this case, we're going to call it a fall because it's a negative. So fall over run. In other words, down and over. Y-intercept, do remember that it's in the form of 0, comma v, and the v value in this case is 2. So it's 0, comma 2. So that's our y-intercept. So let's plot the y-intercept. But let's first remember to plot, or label, I should say, the x and y axis. So first dot, there we go. There is our first dot location, the y-intercept. From there, we're going to move according to the slope. You're welcome to build a table if you choose to, but this will work as well. So we're going to go down 2 over 3. So down 1, 2, and over 1, 2, 3. And there's our next dot location. And down 2, 1, 2, and over 1, 2, and 3. And there's our next dot location. And repeat it again. Down 1, 2, and over 1, 2, 3. And now we can make a line of S fits, or in other words, trace a line through all the dots. There we go. So we graph using our slope and our intercept. We can just as well graph using our calculators. So take out your calculator in this case. It may look something like this. So your calculator, go ahead and turn it on. Very bottom left button, it's the on button. Once it's on, it's flashing like minus right now. Go ahead and push the y equals. Very top left button, y equals button. There we go. And we're going to put a negative sign. Be aware, you're going to use the negative sign right next to your enter button. Your enter button is at the very bottom. There's a negative sign right next to it. Not the subtraction sign, it's the negative sign. So negative 2, we're going to hit the division sign, divided by 3. And now your X button is right next to your alpha button, or on the opposite corner of your second button. So X button. Negative 2/3 X plus, so plus 2. And there's our equation. Now we want to go to zoom, middle top button, zoom. And we want to do a zoom standard. That makes it a 10 by 10 window size, option number 6. So 6, there we go. Now we can see our graph, and it sort of looks like what we have currently on here. Yep, let me go back to my graph. And now we kind of have a rough visual overlay for you, for reference. So there is our sketch. You're welcome to see the tables from here. If you push the second and the graph button at the very right, it'll give you your tables. And if you were to be filling a table, you can fill in from here. So you can use this table to fill in your table. I recommend doing at least one calculation to show that you know how to well do the calculations, but then the rest filling from your table. So push the graph button at the very top right. Your graph button once again shows you your current graph. You can hit the trace right next to your graph button. There's a trace button. And that allows you to move left or right on your graph. If you push 0, it gives you your x value is equal to 0. Hit enter. And it tells you your y value is, in this case, 2. Just like what we have previously. Okay, so now let's try for the next portion. So continuing on. Okay, so it says to use the equation. P equals, for our example, let P be the percentage of people in town who use tax preparers a 2 years since. And then we have a date. Since 1980. Okay, so our equation P equals 0.09t plus 39. Hint, convert your slope to a fraction. So how do we convert our slope to a fraction? That's going to be the tricky part. Well, not too tricky. So let's go back through this and review fairly quickly on that. So reviewing a little bit. Converting a decimal to a fraction example. If we have, for instance, 0.165 as an example. and we want to convert this to a fraction. Well, we put a fraction sign and put 165, since that's the number after the decimal. If there was a number before the decimal, we would include that number. Okay, so do be aware of that. And now, however many numbers after the decimal, but first, we put a 1 always at the bottom. Always put a 1 first. Now, however many numbers after the decimal, you're going to add the zeros. So after the decimal, there's 1, so we add a 0, 2, so we add another 0, and 3, so we add another 0. So for this case, we get to add 3 zeros. So it's 165 1,000ths is what our fraction would be in this case. And we always want to remember to simplify if possible. So in this case, they're ending in a 0 and a 5, so we can divide by 5 in both cases. 165 divided by 5, well, gives us 33. 1,000 divided by 5, 200. Be aware, you can use your calculator to help you out. Your calculator is a powerful tool. Remember, it's a tool. It shouldn't be doing this completely for you, but it's just a tool. Hit clear if you haven't gone out of your main screen. Or if you can't get out of the screen, hit second. Right next to you is the word mode or the button mode. It gives you the option of quit. It takes you back to your main screen, and clear out your main screen if you haven't. So in this case, we can type in 165 and push the division sign, so divided by 1,000. There we go. Hit your enter button to give you a decimal. 0.165, that's exactly what we started with, right? And now, to help you make it more easier for the future, look for the math button. It should be on the left side, somewhere closer to the top. It's underneath your alpha button. So if you push the math button, and now select fraction by putting enter or pushing number 1 on option number 1, which converts it to a fraction. It converts your decimal of 0.165 into a fraction, and it's the most simplified fraction. So it's 33 over 200. So in other words, if you have a fraction that you're trying to simplify, 165 over 1,000 divided it out, or in other words, get a decimal, and then convert to a fraction, and it gives you the most simplified fraction. This could also be used as a tool to check your answer, see if you got the most simplified fraction. So 33 over 200 would be the most simplified fraction. So continuing on with the example, we want to convert 0.9 into a fraction for our particular example in this case. So 0.9, convert to a fraction, we do a fraction sign, put a 9 on top because there's a 9 after the decimal, and we have only one, always have 1 at the beginning, but for this case we only have a 0 added because there's only a 9. So a single number after the decimal place. So this becomes 9/10. And in this case, we wouldn't be able to simplify. So there is our fraction then. So let's do a quick sketch then. Going over and graphing this. Notice that since our fractions is 9 over 10, that's our slope technically. Increments that I used in this case are, notice I went half marks going up the y-axis, but I went up tens. So 10, 20, 30, 40, etc. And the half marks, so you can see in between there. On the x-axis, I went once again half marks, and it made sense to go by tens as well, because my fraction is pretty close to being 10 over 10, but in this case it's 9 over 10. But it'll make it easier in the long run. Let's put a label at the top to hopefully make it easier to understand what we're talking about. It's percentage of people who use tax preparers in the town. Okay, P, percentage, is our Y label axis. And T is our X label axis, years. And our equation, general format, y equals mx plus b. Yes, it is in that format in this case. Our equation is p equals, now for our fraction, or a decimal, 0.9, got converted into a fraction of 9/10. So there is our equation now, converted from p equals 0.9t plus 39 into the equation p equals 9/10 t plus 39. So now our slope, notice our slope is just 9/10 as we previously talked about. And our y-intercept, keep in mind, this is in the form of rise over run before I forget. And our y-intercept is 0, b, or in other words, in this case, it's the 39 that we have at the end with no variable. And we can try doing a graph in this case. Let's plot the y-intercept. So now that we plotted our y-intercept, we can go to the next step using the slope to graph. The slope tells us to go up 9 over 10. In other words, the rise over the run. So we can make more points based on our slope. So going up roughly 9 over 10. There you go, there's our next dot location, and we can repeat this as many times as needed. So roughly up 9 over 10, and once again roughly up 9 over 10, and we can continue doing this as much as needed. Once we figure that we've plotted enough points, well, we can make a line to it. So line of S fits. In other words, in this case, there is our line of S fits. So now we can actually start answering the questions. Notice that we answered the first question. Question A, make a graph. We did. We made a graph. Question B, predict when 66% of the town would use tax repairs. Let's see, roughly where is 66%? Can you see it on the graph there? So there it is. Roughly by the dash marks, I've labeled where 66% is at, going out and tracing it onto our graph, into our line, and tracing it down to the t-axis, x-axis reference. So our years, in other words. At 66%, when it locates onto our graph, it roughly tells us that it's at, I would say 30, 31 years, somewhere around there would be my fair estimate. Do remember, this is a rough estimate. We can't get exact values. It's based on your point of view, okay? So you might be able to see 32 or 29, right, as well. But for my guess, I'm going to say it's 31 years. So B, predict when 66% of the town will use tax repairs. I say roughly after 31 years. Well, do remember, this started in 1980. So 1980 plus 31 years, that means in 2011. So in 2011, roughly is when 66% of the town used tax repairs. Okay. So this will be tax repairs such as maybe turbo, H&R Block, etc. Just as a reference. Okay, and does C, does model breakdown occur? Well, we generally look for model breakdown, or in other words, areas that don't make sense in our graph. Do you see any areas in a graph that don't make sense? Well, if I had negative time, negative years, in other words, it wouldn't make sense because we can't have negative time. We can't predict negative values, right? Since ideally they weren't taken into account. Okay, so in that case, is there anywhere else that it could make no sense or be sort of erroneous looking or oddly looking? So let's see, can we have more than 100% of the population use tax repairs? Probably not, right? We can have just 100%. In other words, the total population of the town use tax repairs. But we couldn't have more than 100%. So look at the top there of our graph where I have an arrow going past 100%. We probably don't want to have an arrow going past 100. It only goes up to 100 and that would be it. So in this case, we can say that this is where model breakdown occurs. Okay, we cannot have more than 100% of the population for this particular town. Okay, so yes, in this graph we do have model breakdown as a reference. Do be aware, you're welcome to graph using the calculator if it helps as well. So, real quick check. Graphing onto your calculators, go ahead and turn them back on. Clear anything you might have on there. Go to y equals, very top left button, and clear the equation that you currently have. That way you don't have error. So clear the equation, and let's plot our original equation, 0.09 or 0.9. T, your calculator does not know t, so you have to replace it with an x. So we are going to say 0.9x. Once again, your button next to your alpha button is the x button, your variable button, plus 39. Now we can try graphing it. So if you go to zoom, do a zoom standard, option number 6. Middle top button is your zoom, and then push option number 6 or push 6. We can't see anything. So we want to try zoom again, middle top button again, zoom. And we want to do zoom out, option number 3. And it does nothing unless you hit enter. So hit enter, and now it starts to zoom out. Hey, look at that. But we can't see what we have currently graphed, right? So hit enter again, and now it zooms out even more. Let's try the zoom button again, zoom, and you want to do a zoom box, option number 1. Hit enter on option number 1 or select number 1, And now move the cursor so you can see where it's at. I want to have it below the x-axis. There we go. I can see it's below the x-axis. So I'll hit enter once, and I'll push up, and I begin to see a line form. So as I continue to hit up, I want to see a little more. There we go, closer to the top. There it is. And now I go to the right, now I can see a box. So essentially we're making a box where we want to zoom into that general area. And you can see the Y value there's 160, so I'm over 100%. So technically, some parts of this graph would not make sense, but it'll serve as a quick check and good reference. So there's my box, I'll hit enter, and it zooms into that area. At the bottom, you can't quite see your labels or your values for X, or at the right, or pardon me, left, you can't see your Y values either. But if you hit trace, this allows you to move in any location. So moving to the right, there we go, that goes past 100, right? So at roughly 70, somewhere around 70 or 68, above 68. After 68 years, there's more than 100%. So that from there on, it would make sense. But before that, we can see roughly the values that would account for it. If I had put the 0 or trace button, I should say first, hit the trace button, top right, second from the right top. Trace allows you to enter any X value. Let's plug in the X value of 0, hit enter, and that gives you your Y value of 39. It's roughly what we have on there. So once again, that is how we can graph using a calculator. Push the second button, and I'll push the graph button at the top right. Second and the graph. It gives you a table, and you can actually see values on there. So 0, year 0, we don't want to account for negative years, so don't worry about the negatives. Year 0, year 1, year 2, year 3, etc. You can see the percentage, how much it increases per year roughly, right? Or what value it is. So if you wanted to fill in a table, I recommend doing one calculation and the rest coming over to your calculator, graphing it, and then entering it from your calculator's table to make your life a lot easier, not to mention to save space. So do remember, calculators are very powerful tools and very useful. I highly recommend it. You learn how to use both a calculator and do it by hand as well. So there we go. In this case, we have both examples completed.